going to do it. So, let us begin Unit 1, Day 1. So, for geometry, the thing you got to know about geometry is that it's all about the words you use. It's a totally different language, and you got to be really particular. Okay? And so I need someone to try and tell me what a point is. What do you think?
It's a zero-dimensional object.
Zero-dimensional?
Yeah.
How does it exist if it has no dimensions?
Just a point in space.
A point is a point. Yeah, that was helpful.
This is undefinable.
Yeah, it's something you can't define. There's a lot of words in geometry that we just say, okay, you know what it is, but we can't officially give it a definition because you don't have any words to use for it. What is a point? Well, it's a dot. Well, what's a dot? It's a point. And so you kind of get stuck. So a point is considered a 0 dimensions. What are the dimensions that we use?
X, Y, Z.
Not X, Y, and Z. You're thinking Minecraft.
Length.
Rating. Yes.
Length, width, and height.
Length, width, and height. Okay? A point has no height. But it also has no width and it has no length, and so it's like it's a tiny dot, but then if you zoom in, it's too big, so then you're like, pick a point in the center of that and zoom into that, but that's still not good enough. Okay? 0 dimensions on this guy. All right? Now, if you see a point, oh look, a point, it is represented with a dot. And then you have to name it. And anytime you name a point, you always use a capital letter.
So I should name him Daryl?
No, because that has more than one capital letter. Has more than one letter. And if you run out of letters in the English alphabet, I got a Greek alphabet on the wall over there you're welcome to use. But we always use capital letters for points, and it's always a single letter. So this one would be point what?
Point A.
Point A. Wow, y'all are so smart. I'm so proud of you. And so, yeah, we represent it with a dot. But the dot is really too big. Because the dot covers up an area. So is the dot way over here on the left side of it? Or way over here on the right side of it? Where is the actual point? And so, you know, you just have to at some point say, it's close enough. It's there. It's that spot. There. That's all you can do. Okay? Questions about points? Yes?
What do we do once we run out of Greek alphabet letters?
Cyrillic.
And that.
Go with Cyrillic. Okay? So, the next thing we have is a line. Someone tell me what a line is. Wait, no, you already answered one. I need a new victim. What do you think, Adrian?
So, the slope of the line, obviously, but in like a segment, it stops at like 2 different points.
Yeah, but what is it? What is a line?
Infinite set of points.
It's a whole bunch of points. It's this point and 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 the one in between them and the one in between them and the next one and the next one. Oh, but then there's a space between them, so you gotta, it's an infinite string of points. Okay? And so it's only one dimension. What is its dimension, do you think? You're not going to shout out. You're smarter than that. You've already answered one. I need new victims. What is the one dimension that a line can be measured? Yes?
Length.
It's length. But it has no width. You can't measure it across the short side because it's technically infinitely skinny. We just have to give it some fatness so we can see it. So this is just a bazillion dots in a row, and because you guys don't want to be cross-eyed and drooling, we consider those dots in a row to be a straight line, okay? And so we want it to be straight. This is not considered a line because it is curvy. It is called a curve. I know, you're impressed. Okay? And so lines have to be straight, but there's not really a good definition for that I can give you without using like college level words. So we're just going to go with when you see it, you know it. If if it looks straight, we're going with it being straight. If I tell you it's a line and it looks not so straight, that's just because I'm a bad artist. Okay? So, oh look, what else do I know about lines?
Plane.
Wrong, that's not a line.
Two lines intersect at an intersection.
You're telling me more stuff, but I just want to know about a line.
Line
It is infinite
Oh, I thought Ray was
length. Well, it is too. But a line has got infinite length in both directions. That's why there's an arrow on each end here. It's to show that I can't keep drawing forever because I run out of time. So I say, okay, I've got this, and yeah, technically it goes on forever and ever and ever and ever and ever, but I'm too lazy to draw the whole thing. But if you see something with an arrow on both ends, that do be a line. Okay? And, let's see, so that's what the arrows are for. So if you want to name a line, okay, you're going to use a little mini line. And any 2 points on the line. So for example, oh, convenient line is convenient. What would be one of the names? There are many names for this line.
Jib.
No, because that's not what I told you to use. I said to use any 2 points on the line. Yes?
Segment A.
It's out. Nope, it's a line, not a segment. Yes?
Line AB.
Yeah, you could call this line AB, because A and B are both points on the line, and so you would say, okay, this is line AB. That's one thing you could call it. But it might like to go by different names with different groups of friends, so I need someone who hasn't raised their hand yet. What's a different thing I could call this line? Ooh, several people. What's one other name you could call it?
Line BC.
Line BC. See, because B and C are both on it. They work for naming it as well. What one were you going to use?
AC.
Oh, you could call it line AC. But wait, there's more. What else could you call it? I could call it line CA. Do I have to always go in alphabetical order? And do I have to always go left to right? No, don't be confined by convention, people. Be free. You can name it in any order, because as long as the 2 points are on the line, you got the right line. Okay? Because, you know, Billy Joe Jim Bob can come from over there, and if you say line CA, he's going to connect the dots, C and A, and boom, it's always going to be this line. Every time. Okay? But sometimes we get lazy, or sometimes we don't know the name of any of the points. You might just have random line here that doesn't have any points on it that we've singled out for interviews or whatever. So there's another way we can name a line if we don't know any of its points. And when we do that, we use lowercase, italic, or can you do italics with when you're handwriting? No, so we use cursive if we're writing. That's the way you do it if you don't know any of the points. So this one here that we were naming A, B, B, C, A, C, C, A, that guy, oh look, there's an interesting little curly guy up here in the corner. That's its name without the points. What is the name of this line? That one is line L. So you would say that would be line cursive L. But you just say L, you don't have to say cursive. What should we call this blue one down here? Give him a name. Follow the convention. What could I name this blue one that has no points on it?
Line.
Yes?
Line A.
Line A, but if I'm going to do the A,
Cursive.
it has to be a cursive A, which doesn't look much different than a regular print A, but if I was typing it on the computer, you would see it was in italics.
Make it swirly.
Or you could make it all swirly and fancy, you know, you do you. Okay, so this would be line A. Woo, fancy. Okay. And then a plane. No, we are not talking about things that fly. What do you think a plane is?
A plane.
You're just, shouting stuff out again. You know better.
A plane is a flat.
Oh, somebody who hasn't answered. I don't think you've answered as much.
A line on a shape?
No, actually, it's not a line. A line is a line. It's all the same people. Come on, guys. Be willing to risk it. What do you think?
It's two-dimensional.
It is a two-dimensional object. Well, what do you think the first two dimensions are? Length and width. But does it have depth? No. So it's basically a flat sheet. And because we are in Euclidean geometry, we are going to assume it is flat and not curved. Okay? Most famous mathematician in the entire world lived like 2,000 years ago. His name is Euclid. Okay? And all the geometry he did assumed that a plane is a flat surface. So a piece of paper would be a good representation of a plane, except it's a little too thick. Planes are infinitely thin. And then it's also a little too finite. Okay? Because a plane, lucky it, extends forever in all directions. So when we draw it, we represent it with like a parallelogram to kind of show that it looks like a piece of paper. It's kind of a flat thing. But technically, this plane is going on forever and cutting off all your heads. Because it's just shooting out off my desk and going over there. But we don't have the bandwidth to hold it all, so we just draw this much of it. But it'd still be going.
Our universe could be like a plane.
Yeah, but our universe is four-dimensional. And so then you're getting into the non-Euclidean geometries of either hyperbolic or spherical dimensions. This is college-level geometry here. And yeah, it do not be flat. It has flatness in it. You can find flat planes all over the universe because, well, look, this table is part of a flat plane that's going on forever. Okay? This is just a big, piece of wood in it. But yeah, this is a non-Euclidean plane. This is a spherical plane.
Yes.
It goes on forever. I can just keep going and going and going. But it's not infinite. It's bounded. It stays in one spot. So this is a different kind of geometry that y'all don't get to learn.
The universe is shaped like a saddle.
Which is the hyperbolic geometry. That's the other type. This is spherical, that's hyperbolic. Except that, remember, the universe is four-dimensional. And a saddle is like a curved plane. And so the space itself, including time and stuff, it curves around things with mass. That's what makes gravity happen. And you're like, I did not expect a college-level physics lesson in my 9th grade geometry class. So let us continue instead talking about plane. Flat thing goes forever. Got it? Okay. And we represent it by typically drawing just a parallelogram. And I'm too lazy to write the whole word parallelogram, so I just put parallel/gram. Because I'm too lazy. And when you name it, that should have an M there. Okay. How do I make sure I am naming this exact plane and not a different one that's just a tiny bit tilted away from it? Yes?
Plane F?
I could just put a fancy script, cursive-y, fancy uppercase letter on it. So the first way to do it is like a script or cursive uppercase letter. So this is plain fancy S. or just plain S? But sometimes we don't know its official name. All we know are the guys hanging out there. Here, what are the names of the points hanging out on this plane?
A, B, and C.
Wow, creative. They're A, B, and C. Okay? How can I name it using letters and be sure that I'm getting this exact plane and not a plane that's going this direction? Did you want to cheat and read ahead or something?
Well, I mean, I study everything in the summer, like before the course happens.
Oh, so you're like my daughter, Rebecca. She does that too. Okay, how?
You would name it the plane ABC.
Yeah, so to name a plane, you can't just use two letters. Because if I just use two letters, there's lots of planes. So if I just use A and B here on my whiteboard, oh look, the whiteboard is a plane that contains this line, isn't it? But I could also take a piece of paper, and it could be going this way, and it's hard to do because paper's floppy, and it would also contain that line. And so just using two letters only gives me a line. So to get the full plane and make sure I've got it, not just this part, but which direction it's going in the third dimension, I need 3 points. So I'm going to use 3 points on the plane. Okay? And so if I use points on this plane, what is one of its names? Someone who hasn't answered yet, here's your chance to shine on something you can be pretty sure about. What could I name this fella right here? Yes, what do you think?
Plane ABC.
I could name it plane ABC, but don't limit yourself. It could have aliases. Yes?
CBA.
This could be plane CBA. Yeah, you answered stuff. New victim, yeah?
BAC.
This could be plane BAC. All sorts of fun we can have naming them. They just have to be on the plane. This is why, my friends, tripods are better than four-legged chairs. Because with a tripod, you've just got 3 points on the end, right? Those 3 points will always be on a plane. It might be a slanty plane, but if you have any 3 points, you can find a plane that will contain all 3 and name it. And so it will always be sturdy. But 4 of them, where's my wobbly one? This one. 4 of them will not always be on the same plane. 3 of them will always all be together. So here I've got, those 3 together, and then the one back here doesn't quite touch. All 4 of them don't have to be together. But 3 of them are always together. That's why camera people and movie makers and people who, the little camp stools, anything with 3 is always more stable because you can always define a plane. So these are considered, these 3 things are the undefined terms of geometry. And you're like, wait a minute, I thought we just defined them. But these are kind of loosey-goosey, squishy definitions that you can't nail down. And so technically, no, they're undefined because we can't give it a hard, these are the proper words to use to name it. Okay? So undefined terms. Now, all this year, we're going to be doing a bunch of stuff with logic. And we're going to be doing things called implied statements, where if the first thing happens, the second thing has to happen. So, if there is a cute frog, Mrs. Cerna will want to catch it. That's what I did this morning in my kitchen. Cute little frog, I caught it, okay? An implied statement just says if the first thing happens, the second thing has to happen. And so with these, there are a couple of implied statements that we can say are true. So for a line, we can say that any, let me make sure I'm in the frame here, any 2 points implies that you have a line. I did that where yeah, right here. 2 points, and this little arrow guy with the double lines pointing for emphasis, that just says implies. That means if the first thing happens, the second thing automatically happens. So if you have 2 points, you know you got yourself a line you can draw. That makes sense, right? You've been doing connect the dots since you were like 4, right? Okay. But guess what? What if you have a line? Then you automatically know that it can be that you can find 2 points on it. So this actually goes both directions. 2 points implies a line, but a line also implies that you can find 2 points on it. You're like, whoa, mind blown. I know, it's amazing. Think you can memorize that before the end of the school year? Think you can memorize that before the unit tests? What does 2 points imply?
A line.
Wow, geniuses. Okay, so that's your first implied statement. Okay? We need more. Give me more. Oh, look, convenient plane is convenient. What will ensure that I always have a plane?
3 points.
Hold on. This is where there's a catch. What if I have 3 points that are all on the same line? Is there just one plane that goes through these 3 points? No, because I could again couldn't I take a piece of paper from this direction and touch that line? Oh, and could I take one from this direction and touch the line?
Yep.
And this direction? So those 3 points don't just give me the plane of the whiteboard. There's a zillion planes that can contain that line. So 3 points in a line do not give you a single plane, because I could just send it going in any direction I want. Well, crap, how do I say it so that I get a plane, but I don't make the mistake that I just had on the board? What do you think?
You have 3 points that are not in a line.
3 points that aren't in a line. How can we say that without so many words? Oh, I got it. I'm out of space, so I'm going to write up here at the top. Okay? You put it wherever. So how about 3 non-collinear points? What do you think collinear means?
They're in a line.
Co means together, right? So together on a line. But I put non, so 3 not together on a line points. 3 non-collinear points defines where a certain plane is. So if I have 3 non-collinear points, I know exactly one and only one plane contains all 3 of them. Okay? Because the third, one of them kind of tells you how far left, how far right, and then how far up and down. All 3 dimensions. Okay? But wait, if I have a plane, guess what I can always find?
3 non-collinear points.
3 non-collinear points. So it is biconditional. It goes backward and forward. So if I say, oh, guess what? I have a convenient plane. What can I imply? That I've got 3 non-collinear points I can tell you about. Are there more points on a plane than just 3?
Yeah.
Well, yeah, but you can name 3, and that's all you need, is to name it with 3. Yep?
So,
I forgot to close the door, and that's a big no-no. So I'm going to close the door.
you said that the 3 points, like the left, right, or up and down is all 3 dimensions? How is it all 3?
Because left and right are 2 directions.
Like dimensions?
So length, width.
Like, I thought, because like
Oh,
left and right is both.
oh yeah, it's 2. You're right, it's 2. You caught my mistake. Get candy. 2 dimensions for a plane. Because it's flat. It don't have depth. Bark, 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 Mrs. Serna. Okay. Have I confused you enough yet on that? Shall I confuse you some more?
Yes.
Of course we shall. Moving on. 2 lines. Ta-da! They cross each other. What do they intersect at? Put your pen on where they intersect. What did you just draw?
A point.
A point. So two lines intersect at a point. Wow. What about two planes? Well, don't call stuff out. I want you to take your pen or pencil and trace where these two planes are touching each other. Imagine building it, imagine tracing it, and oh, it's going to be right here. But wait, don't planes go on forever? So isn't this really continuing down here and really continuing up here? Technically, they're going on forever. So two planes will cross each other at a
Line.
line. Wow, it's magical. Let's look around. Do you see any planes intersecting? Oh, wow, the ceiling and the wall. If you trace where the ceiling touches a wall, guess what you're tracing? A line. But since it's not infinite, you know, you run out of time. Okay, what about a plane and a line?
A point.
Sometimes. Sometimes a plane and a line intersect at a point.
So it can be a point or a line?
Okay. And so here's how a plane can intersect a line. It can go right through it. Very satisfying when you're in that kind of mood. So this line can intersect this plane in lots of directions like that. And it only ever intersects at that one spot, no matter which direction it's going, unless. So yeah, we've got a point. See, it's intersecting right there, unless, asterisk. When would it not be touching? You're not going to call things out. I want people, no, everybody be looking and thinking, how can I make it so that this line is touching the paper, but in more than one point? Got some people thinking about it. What do you think, sir?
If it's running along the plane.
Yeah, if it's laying in the plane. If it's coplanar, if it's in the plane, it touches along its whole length. And so unless it is coplanar. Okay? Ah, so satisfying when you get to stab it through the paper and get that one point right there. So fun. Okay? Continuing on, more words. You're like, wait, this is almost like a language class. Yes. In my college, upper level math is a foreign language. You get foreign language credit for it. I did not have to take foreign language in college. I just took advanced math. In some schools. At BYU, music was also a foreign language if you took it high enough. Yep, good times. So we go, all right, a segment. What's a segment? What's it short for? What's a segment? Nope, you've done enough. Gotta make other people suffer. What do you think a segment is short for?
A line.
Close. It's short for a line segment. Guess what a line segment is? A segment of a line. What's a segment? A piece. A line segment is a piece of a line. Okay? So it's a portion or a piece of a line. So if it's only a piece of it, does it go on forever? No. So we don't put arrows on it. No arrows. Because it stops at both ends. It has a definite endpoint on both ends. Definite endpoints. Can I have a victim who dares to guess what you think the endpoints of yon line segment are? Oh, people who haven't raised their hands yet. That would be amazing. Yes? Yeah, the two endpoints of that segment.
Aren't they just a point? Because it ends it like that.
Well, it's got a point on each end. That's why they're called endpoints. Yeah, but then there's all the points inside it too, because it's a piece of a line. But what are the names of the endpoints of this guy?
Point J and K.
Point J and point K are the end points of this line. So there's one, and there's one, right here. Those are the end points. Which one's the start point?
We don't know.
We don't know, and it doesn't matter, because if I flip the thing over, it's the same guy. It's the same forward and backwards, so nobody cares. Okay? And so to name a line segment, how do you guys think we could name this so that if somebody walked by, they would know exactly that I'm talking about, this guy in particular? Come on, somebody hasn't answered so much yet. You in the white sweatshirt here, what do you think we could call it? How we can do it?
You can just use a letter.
Which letters?
L and M.
Oh, but that's down here. We're on this guy up here.
Oh, J and K.
J and K? Why would I use J and K instead of, like, if I had Q right here, should I use Q?
No.
No. So why J and K?
Because they're the
Him! I'm asking him why he chose them.
They're the only one that matter.
They're the only ones that matter. The ones on the ends, so that you know where to stop on each end. So you name it using the endpoints. And I'm lazy, and so instead of writing point, I just put PT, and I'm going to do that all year. Okay? So I'm going to use the endpoints, and then, so you say this will be segment JK? How do I show that it's a segment and not a line when I say its name? How can I show that this is only a segment and not a line like I had up here? Got some more brave people. What do you think, sir?
I think you draw a little mini segment.
A little mini segment on the top without ripping your paper, please, Mrs. Cerna. JK, aw, it's so cute. But remember, JK has an evil side. If he starts going all backwards and stuff, what's his evil name called?
KJ.
Segment. Don't forget the segment part. KJ. So he's got two names. And it doesn't matter. They're both just as valid. So if you're feeling just like left to right, boring, cool. If you want to go the other way, you can do it.
So do you put points on both ends or just
You got to have both ends. Because otherwise you don't know where to stop on the other side. You have to have, when you're drawing it, you have to know where one end is and where the other end is. Because if you don't know where the other end is, you might think you have one of these guys. And what is this guy? This is a ray. Oh look, Mr. Ray, what makes a ray a ray? What do you think, Red?
One side has an endpoint and the other side has an arrow.
Yeah, so it is another piece of a line. But it has one endpoint. So if you take a line and cut it off anywhere in just one spot, you suddenly got rays. Ta-da! And so the other end, look, it has an arrow on it. So this end is still going on forever. So it extends forever in one direction. So this ray is going on forever over here. That's what the arrow tells you. But it has an end point at L. Okay. So rays are tricky. How are you going to name a ray? I saw a hand up.
I was going to ask a different question.
Oh, so what's your question then? Let's answer
That's
that.
why they call it like a ray of sunlight.
Yes! Exactly why it's like a ray of light or something. Because you've got your light source is one endpoint, and then it goes on forever. Because the photons don't stop, they just keep going. So yes, that's absolutely where that comes from. Yay! Connections, real world, good times. How do we name an array? What do you think?
You start with the endpoint, and then you do the...
Yeah, so you start with the end point, which, using words sounds funny, but it makes sense. You start at the end point. So, okay, so let's see, to name it. You start with the end point and use another point on the ray. So what would I call this fellow here? Somebody who thinks you can figure that out? And same people, who has, okay, you with the white scrunchie. I haven't picked on you much today. What do you guess this guy would be called?
LM.
So close, we have to say what kind of object it is.
Oh, ray LM.
Ray LM. And to show that you have ray LM, you draw a little ray and then put the letters L and M on the bottom. Now rays are particular. They've only got one endpoint. So can I name this anything else? Well, yes, but the first letter better always be L. Okay? Because what if I had point Q over here? Then what's another name I could call this exact same ray using different letters? What's that? Ray what? Ray LQ. But for this ray, I can never start with anything but L. If I do, I'm naming something else. If I said MQ, MQ would just be this ray that starts here at M. And you'd be leaving out this whole piece here. And so you never use anything but the endpoint and something else on it. Always got to use them both and put the cute little ray on the top. Okay? Opposite rays. There they are. What do you think the name is telling you? It's not the opposite of a ray, it's rays going in opposite directions. So it's two rays, two rays. Why did I put a P? Two rays from same endpoint and extending in opposite directions. Okay? Well, wait, hold on. I'm going to look over here. I'm going to pick point B. And I'm going to say I have ray BC going this way. So ray BC. What would be the name of this red ray going the other way? Somebody hasn't answered so much. If you've answered yet, what do you think?
BA.
This one would be ray BA. Now look, it looks like it should be AB, but you always start with the end point and go along the ray. So this would be ray BA. And see how they both share the B in the middle. That means they are opposite rays. But if I have two rays stuck together at the ends and going off in different directions, what are they making when you stick them together? They form a line. Forms a line. And so basically, any line you draw, if you pick a point anywhere on it, I've got an opposite ray going one way and an opposite ray going the other way. I could take the same line and pick this point and have opposite rays there, and it's still the same line. Wherever you cut it, you've made opposite rays. Yes?
The little symbol where you put like BA, why doesn't the arrow go the other way?
Because we read in the English language from left to right. And so I read from the left to the right. So this tells me start at B and then go toward A. So then I go up to the picture and I find B and I go toward A. Okay? That's why it's written pointing this way, because that's the way our language works. I'm really interested to know how it works in, say, Arabic or something, or if it goes right to left. But for us, we do it this way because we read left to right. Yes?
What if we were to cut out like a segment instead of just in half, wouldn't it just be the same in different letters?
So, can you illustrate for me what you're saying? Can you come up and draw what you're saying? I don't want to misinterpret.
So instead of just the B, there's like a C here and this is a D.
Let's just make this P.
Yeah. So what if we were to cut them out? Wouldn't it just be the A and C?
Yeah, I could have an opposite ray going that's DA and DC on the same line.
You could still call them opposite rays.
Yes!
On a question. Okay.
Yeah, they're still opposite rays. They just have a different endpoint on the same line. Good question. I like that. That's the kind of thing I want you asking. If you're something like, well, what happens if? Ask me the what happens if. Okay? Those are the kind of things we want to know. Because that means you're thinking and then you learn the more stuff. Okay? All right, continuing. Midpoint. Who thinks they can tell me what makes a midpoint a midpoint? Nah, you've answered a bunch too. Don't even ask. What do you think a midpoint is? Yellow. It's a point in the middle of a what? Can you be in the middle of infinity?
No.
Yeah, infinity has no middle. So can I have a midpoint on a line? Can I have a midpoint on a plane? No. Can I have a midpoint on a ray? No, because they go on forever. So the only thing I can have a midpoint on is a segment. So a midpoint is a point on a segment that cuts it in half or divides it into two congruent parts. And so we say that it cuts it into two congruent pieces. And see this cute little symbol, the equal with the squiggle on top? That's your symbol for congruent. That's how you say that shapes are the same size and shape. Okay? So two segments that are the same length and they're both segments, they would be considered congruent. Okay? Equals is for numbers. Congruent is for shapes. And so this midpoint right here is cutting this segment into a congruent piece on the left and a congruent piece on the right. And look how I marked that they were congruent. How do I know that this segment AM is congruent to segment MB? How did I show it on the picture? Yes? These little hash marks. They're called hash marks. Anybody play football? And you've got the hash on the field, the little hash marks that show you how far out to the side you can go to kick and all that stuff? Yeah. So these hash marks are how you mark that things are congruent. So if they have the same amount of hash marks, they're congruent. So what are the two congruent pieces of this line segment? What's one of them?
A.
A is a point.
AM.
AM. This piece here is segment AM. Which piece is it the same length as? Because M was the midpoint. Yes, sir?
MB.
Segment MB is the same size. And so I could say that AM is congruent to MB because they are the same size. How do I know they're the same size? Because this is a midpoint and it cut it in half, and I marked it with the little hash marks that said they were the same size. Yes?
Wait, so on a midpoint, does there always have to be an odd number of points?
Well, you need the ones on the end, and you need the one in the middle, so yes, there are always 3. Okay? The ends and the middle. Always got to have 3 there. Okay? So, we get another implied statement here. If you have a midpoint, that is always going to imply that you have 2 congruent collinear segments. Why did I have to say collinear? Because they're both on the same line. Okay? So if I happen to have random segment over here and other random segment over here, and I tell you, oh yes, for sure, those are congruent. But see how they're not collinear? They're not on the same line? So do I have a midpoint over there? There ain't no midpoint over there because they're not collinear. They have to be collinear and share that midpoint. So midpoint implies 2 congruent collinear segments. What if I flip it? What if I have 2 congruent adjacent collinear segments? Will that tell me that I have a midpoint somewhere? Yes. So this goes backward. I forgot to, where's my, I think I skipped another implied statement.
Opposite, right?
Oh, yep, I did. I skipped one. I am ashamed. I have to go back. Here I had 2 points implied a line. Oh, I didn't forget it. I just wrote it up at the top. 3 non-collinear points is a plane. I didn't forget my other implied statement. Phew. I'm relieved. I had scared myself. Okay, now here's the most confusing thing we will do today. What's a segment bisector? What do you think?
A line that goes through a segment.
That's a version of a segment bisector, so it could be a line. Yes?
A line going through the midpoint.
It could be a line.
That's not the same.
But guess what? It could be a ray. Or it could even be just a segment. That cuts through a midpoint. Or we sometimes say that as intersects at the midpoint. Because we've got to use our fancy math words, right? So a line, array, or a segment that intersects at the midpoint of a segment. So here is AB. It is being a segment. Okay? What is the name of the midpoint of AB? Hand up. What is the name of the midpoint of AB? Find it on the picture. Where is it? I want a few people's hands to be raised before I pick on a victim. Y'all need to be able to identify midpoints. Look at the picture, find the midpoint, raise your hand. Some people are not paying attention. You're not very good actors. Your hand should be up if you know. Okay, sir in the black, what you got?
M.
M is the midpoint. Now, is there a line or a segment or ray cutting through M? Yes, it is this other line that has no name. Let us name the line. Somebody give it a name according to our naming rules. Let's see. Give it a name you like. What's a letter you like?
Line G cursive.
G cursive, and it would be a lowercase g, so cursive G. So line G is the segment bisector of segment AB, because the line cut the segment through its midpoint. So see how G is going right through the middle there? Is M the midpoint of G?
No.
No, you can't have the middle of an infinite line. Okay, there's no middle to infinity. You don't want me to get into those arguments. I have way too much fun with them. Okay? And so because of that, we get another implied statement to memorize. So your implied statement for this one is that if you have a segment bisector, now I'm lazy. I don't like to write the word bisector so much. So I take a number 2 and cut it. Because when you bisect something, don't you cut it into 2 pieces? So a segment bisector implies that I am intersecting, look at that upside down U, dude. That is our fancy math symbol for intersecting. So a segment bisector implies that you intersect at the midpoint. Yes, I am that lazy that I use that many symbols. If you need to write it out in words, you can. Segment bisector implies it intersects at the midpoint. Okay. And so that's another one. You get to memorize that. Aren't you excited? I've got a whole Quizlet up on the computer in today's module that you could go to, and it has them like in little flashcards. So you can see, ooh, segment bisector, what does that imply? And then you guess. Intersection at midpoint. But if it shows the intersection at midpoint, does that go backwards? Does that imply that you must have a segment bisector?
Yes.
Yeah, because it's a definition. So definitions go both ways. So this goes forward and backward. Yes?
I think most of the time that an implied statement can go both ways.
Only if it's like a definition. We have a lot of implied statements that do not. Okay? We will get into that in Unit 2 in our logic unit. Okay? We don't want to have too much fun now. Okay, turn the page over. What did collinear mean again? Do you recall? I said that one before. What was collinear? Pink shirt. What did collinear tell us? Collinear. Together on a line. So they're points on the same line. That gets an implied statement too. Basically, it's the definition. Okay? If you say that points are collinear, it implies points on the same line. Any definition can be written as an implied statement. And if it's a definition, it goes both ways. Wow, you're so scared. Try not to cry. So what's coplanar going to be? We talked about coplanar.
2 planes.
No, not 2 planes. Good guess. Co means together, right? So together on a plane. So it's any 2 things on the same plane. So if you have 2 lines that are both on the same plane, they're coplanar. If you have points on the same plane, they're coplanar. 2 rays on the same plane, coplanar. 2 triangles on the same plane, coplanar. Okay? Are the posters on that wall and the posters on this wall coplanar? No. Those posters are on the flat plane of that wall. These posters are on the flat plane of this wall. They are non-coplanar. They are not together on a plane. Okay? And some people really struggle to get that mental image of 3-dimensional and how those are and stuff. And I'm sorry if your brain just struggles with that, because some people's brains are just better at it than others, but you're going to be fine anyway. You will survive. I promise you. I will not let it kill you. Okay? And so this gets an implied statement. Okay? So if you have coplanar lines or rays, etc., whatever they are, what does it imply? implies that whatever thing you had over here, so lines or rays or whatever, are on the same plane. Remember, anything that's a definition can be written as an implied statement, and then it can always go both directions. You could say, what if I have lines on the same plane? What does that imply? That they are coplanar lines. Or I could replace lines, I could say rays, I could say points, I could say fish, I could say turkeys, whatever. If they're on the same plane, they're coplanar. Okay? Having fun. Almost done. When do we get out of here? Yes, we're going to have time to finish. So if we have closed figures here, that's just a shape that's all the way closed like a rectangle. If you're going to name this guy, you're always going to name a closed figure by picking a point to start. On a vertex. Okay? And then go clockwise or go counterclockwise. Okay? So this rectangle up here, someone pick a starting letter to name yon rectangle on the left. Let's see, green shirt with the stripes. Pick a letter.
B.
Thank you for not picking it. If I decided to name this one, starting with B, I would say it was rectangle B, and then what would I have to say next? If I'm going clockwise. C, and then D, and then A. Do not skip letters. And do not zigzag. Okay? What would be a different name for this same rectangle going clockwise? It would still be a rectangle, but what could be one of its aliases? Yes, ma'am.
CDAB.
Let's see. She said start at CDAB. I'll buy it. CDAB. Same guy. She just started here. Gives you the same thing. What about going counterclockwise? What's a thing I could name this one if I decided to go counterclockwise? It's, going to work real similar. Yes, sir?
The two A, B, C, D.
I could do A, B, C, D, because that's going like that. What could be an alter ego for it? Yeah?
D, C, B, A.
I could do, D, C, B, A would be clockwise. This one specifically said counterclockwise.
A, B, C.
I could do D, A, B, C. You can go either direction. I don't care if you like clockwise or counterclockwise. Typically, if we do one, we math teachers like to have fun. We'll do something like that. And if you do the letters in the right order, it spells a word. And so we tend to like it. You could call this rectangle AGEC, but it's more fun to call it rectangle what? Cage. Yeah, it doesn't matter. As long as you're going around and not skipping anything, you're good. Okay? Applying it to triangles, nah. Triangles are too easy, so we're going to skip that. Parallel lines. Parallel lines are shown to be parallel with these little arrows, extra arrows that are not on the ends. Because lines always have arrows on the ends, right? But see how line AB is parallel to another line. What line is it parallel to?
CD.
It's parallel to CD. What do you think is the magic symbol that I put in between them that says they're parallel?
Two lines.
Two parallel lines. Should I make those parallel lines go like that? No, because then what will we think we're looking at? Equals, and we don't want it to go that way. So parallel goes up and down. And see, look, they're marked with these extra arrows to show that for sure they're parallel and they aren't slightly cockeyed. Okay? They are for sure parallel. What's another set of parallel lines here? And somebody get interesting, name it. Don't be boring. Another set of parallels. Go for it.
Wait, C and D?
CD, we already did CD. We did these blue ones already. What's another set that's not blue that are parallel?
BD.
BD, line BD, and what's it parallel to?
AC.
Line AC. And they're different parallels because these ones have two little arrows on them to show that, yeah, these guys are parallel to each other, but they're not going the same direction as the single arrow guys. Okay, that's how we tell those. Okay, that's not supposed to be there. Be gone. No parallel planes here. We're not doing that. What about perpendicular lines? What makes lines be perpendicular?
90 degrees.
Oh, but your hand wasn't up. Yeah.
Oh, intersecting like a ray.
They have to intersect. So perpendicular intersects at a right angle. See the little right angle there? So this is my intersect symbol. Intersect at a right angle. That's what makes them perpendicular. Okay? So how could I say the lines that are perpendicular in this picture? Someone tell me the lines in this picture that are perpendicular. Yes, go for it.
Line CD.
Okay, so line CD. Could I have called this line CE if I wanted to?
Yeah.
Yeah, but she chose CD, that's fine. Okay, next victim, what is CD going to be perpendicular to? Yes, AB. So CD is perpendicular to AB. I need a symbol for perpendicular, because I'm too lazy to write that longer word all the time. What do you think? No, because a plus symbol, yeah, it's perpendicular lines, but we use it for plus, and we don't, so we can't use that. So what do we use instead?
Upside down T.
We use a set of perpendicular lines that don't cross, and some people say, yeah, it looks like an upside down capital T. But it's not really an upside down T, it's a set of perpendicular segments. Yeah.
Are those two opposite rays intersecting too?
Yes, but they're intersecting at just a point. Okay, and we're not intersecting at right angles. Opposite rays are intersecting in opposite directions at 180 degrees. Perpendicular things intersect at a right angle. Okay, excellent question though. I like it. Okay, congruent sides and angles. What's congruent mean?
Equal, same.
Not equal.
Same shape.
Same shape and
Same size.
same size. So in this picture, tell me something that's congruent in here. Yes,
The shape.
we don't know that. So we have to look for what's marked the same. Remember the little hash marks tell us things are congruent. So what are some things that are congruent in this picture?
The line's length. Each line's length.
I can't hear you, what?
Each line's length.
Okay, so each segment you mean?
Yes, segment.
So AB, this segment right here, what thing is it congruent to?
D and E.
Not D and E, you just say segment D, E, because they each have one little hash mark. What's something else that I can tell from the marks is congruent in this triangle? Yes?
Segment AC.
Segment AC is congruent to which one?
Segment DF.
Segment DF. Anything else in this picture that I can tell is congruent? Yes?
Segment CD
Uh-huh.
and segment FE.
And segment FE. They are also congruent. What about over here to the right? What things are congruent in this picture? Yes, what's something?
Line segment AE and line segment DE.
And line segment DE, they are definitely congruent. Let me color those guys in. This guy and this guy. What else is congruent? Yes. things that can be the same size and shape. And so this guy, see how it has just one little hashi mark there curving through it? And this guy only has one? So to say that, we say angle is, you draw a little angle with a curve through it. Angle A is congruent to angle D. And then what's another thing in this picture that's marked as being congruent? Yes? Yeah, angle B has two little marks, and angle E has two little marks. So you could say angle B is congruent to angle E. Okay? And so remember, congruent is objects that are the same length or measure, maybe they're the same angles, maybe they're the same, depth, something. The objects that are the same length or measure, okay? And guess what? If you have a congruent segment, I was going to say segment and I put a G. Ms. Acerna, get a grip. If I have congruent segments, guess what I know for sure about them? They're the same length. Well, length is a number, right? And so we use equals for numbers. So if you have congruent segments, it implies that those segments have equal lengths. Okay? So when if I say that you two people are congruent, if I measure one of you and it's 64 inches, the other one better also have the length of 64 inches. Congruent things have equal length. Well, if I have equal length, what do I probably have? Congruent segments. So it's biconditional. It goes forward and backward. So if I told you, I'm going to make up a picture in my head. I've got it. Here it is. So I've got a random segment KL and another random segment MN. They are drawn in my brain. You cannot see them. But I tell you that they are congruent. What could I say for sure about them? Yes? How would I show their length? How would I write it? Yes?
Numbers.
I would, but I don't know their numbers yet. So what I do is I say, I need to just find a way of showing you that I'm talking about the length of KL, that number that we don't know. So what I do is I say the distance from K to L, and I just put the letters. So if you just put the letters, you're really talking about a number, a length. If you put the bar on top of it, you're talking about the actual physical piece. So if these two things are congruent, this length has to equal this length. This number has to equal this number. They are different, and I will take points off all year if you try and put a length thing for a segment or a segment symbol for a length. If you're talking about the thing, draw the picture of the thing. If you're talking about a number, you're just putting the letters you're measuring between. Okay? For angles, if I say angle Q is congruent to angle R, what do I know about those two angles? They have the same number of degrees. And so we say the measure of angle Q, however many degrees it is, equals the measure of angle R. And so that gives us one more implied statement. One more. Okay? If I have congruent angles, what do I know that I have for sure?
Do equal degrees.
I have equal, and I'm going to say measures. Equal measures. Okay? You survived. That took longer than I wanted to, but that's okay. We're going to be fine. Okay? So what I want you to do is pull out the homework worksheet you picked up. We're just going to talk about it real quick. This guy. Let me show you what you're going to do so you don't do it wrong. Right here, where it says define the term, you're going to say what it is. So a point is a location. Maybe you'll say it has 0 dimension. Then I want you to draw it and name it. So how do you draw a point?
So point,
You make a dot,
so like A.
give it a name, do it in the right one so it has to be a capital, and then so I drew it. This would be point A. It's drawn and it's named. Okay? If I had to do a line, what is a line? You would put whatever we said a line was. Then over here, you would draw a line, and then you would have to name it somehow. So maybe you would put K and P on it, and you could call this line KP. Or if you were feeling fancy, you could put a little fancy Q on it and call it line Q. Whichever. Okay? So you're going to put its definition, make one up, and then say its fancy math name symbol. Okay? Go ahead and pack up your junk. We will not always have notes for that long. Today just went kind of slow. Okay? Thank you for your patience.
You already got it.
I'm trying on getting another one. I'm trying on getting another one.
Bye, Miss Sarah.
Bye.
Technically, you always do it, and you know.
Yeah, but you
Right, now it's equal out.
Bye. Oh, okay. Let's see it.
You're okay? Huh? You're okay? It's on my phone.
Yeah, don't forget your phone. Nice. That's fine. That'd be great. So drop it off on the desk and then grab a candy.
Does it matter
Yes.
which number we put it in?
Not today. I'm going to assign those sometime, but this is not that day. Just somewhere on the desk. Thank you so much. I appreciate it. Go for it. You make a better wall than you do a window. Oof, I told you.
Next time.
I told you.
you're going to grab 2 papers out of that first stack and staple them together because our copier is out of staples. And, oh man, it's got somebody's missing one. Oh, that one doesn't go with it either. Yeah, this one. Day 1, day 2, day 3, day 4. Those two go together. Thank you. When all else fails, read the instructions. Don't forget to put your phones up as you're getting your papers. See, it gets excited sometimes. It's like, oh, let me put in a bunch. Say again? For today? Last time? Okay. So you were gone, so let me... Oh, no, so you had to get the green paper time. And then there was the algebra practice. I'll be picking all that stuff up. Don't worry. Once you get, oh guys, oh man, now it's all messed up. Just grab 2 off the top. Day 1 and day 4, day 1 and day 4, day 1 and day 4. Here's day 1. Take a packet of 2 and staple them together. Who else does not have their day 4 pages for their algebra review? You should have a day 1, 2, 3 on one page and then day 4 here. If you do not have a second page of graphy things, you need to come and get it. And then staple them together so they are not lonely. You have them both? Yes. You have them both?
Yes.
Awesome. Excellent.
So, the first 2 we staple together?
Yes. Yeah, the ones that say take a package of 2 and staple together.
And then this one we...
And just hang on to it. Are they backward again? Somebody else grabbed a day 1 without a day 2, 3, and 4. Make sure that you have 2 pages of graphs. Day 1, 2, and 3 are on one page and day 4 is on another. Please check and make sure you have them both. We did the crossword and the algebra. But the crossword was for Candy and the algebra was for Greg.
Okay, can I turn it?
I'm going to tell you how we turn stuff in. I'm going to teach it all.
So we get 1 from each pile?
No. What does this one say? Somebody else did it. Dang it. Take day 1 and day 2. 2 pages. Did you take 2 pages? No. There's day 4. Did you take 2 pages? No, ma'am. There's day 4. Staple the days 1, 2, 3, 4 together. Here's day 1.
That's such a cute photo.
I will tell you what to do with those in just a second. You get all of these. Like that. Just take one here. Pledge!
America.
And to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. Texas is there in the back.
Now the Texas pledge.
Honor the Texas flag. I pledge allegiance to thee, Texas, one state under God, one and indivisible.
One and indivisible. Students have a few announcements today. Are you a scuba diver?
I don't like it when they go too slow.
The Wilkes High School Scuba Club
Okay.
is the first meeting of the year, Monday, August 15th.
You remember. Good.
Senior campus in Elchia.
So, phones should be on the wall. That should be something to do as you go in.
Each meeting you
I can't
attend
hear,
this year,
Pete.
get your name and address.
You should be, pull out the packet that you stapled
Certified to attend our meeting.
of graphs and do the day one problems. This will always be your warm-up, it's just one day of problems.
Monday, August 15th.
So do the day one algebra
At the
stuff.
senior campus,
Do you
we
need
have
day
a period
four?
at
Do you only
6
have one page?
All are
Yeah.
welcome to join.
Okay, give her a day four.
Students, we've already started accumulating lost lunch bags and other items. Please check the lost and found table in the
You need a day one?
cafeteria if you have lost something. Another good place to check is your teacher's classrooms if you feel like you might have left something behind there. I want to make sure we're communicating the Highlander expectations.
You should be working on day one of this algebra graphing.
We'll use the restroom around the corner. in
See if
the
you remember how to graph lines, it's very
And
scary.
we'll make sure to clean up after ourselves when we are finished eating. Make sure we're throwing all our trash away. Bus riders, make sure you know your bus number and its location before we dismiss today. If you do not know your bus number to ride home today, please be sure.
My 10th grader got on the wrong bus yesterday.
Do not
Got
wait
brought
until the
somewhere
end of the
totally
day to
different. It was
ask which
hysterical.
bus you should get on or where your bus is loading. You need to report directly to the bus ramp after dismissal in order to give yourself time to find your bus. Buses do not wait and will not come back to campus to pick you up.
There is a Daniel, very
Also,
Daniel in the room.
Posters are in the cafeteria area so that you know the general location of your bus. And now I'm going to say a few words of wisdom. Have you ever thought about what had to happen in order for you to come to school today? In addition to all the things your parents did to get you here, it took thousands of hardworking people paying taxes so you can have books, dry erase boards, and desks. It took administrators handling details. It took custodians and cooks and security people to provide you with a clean, safe, and nurturing environment. And it took dozens of teachers who care enough about you to work hard so that you can
Sydney?
get an education.
Thank
So
you.
listen up.
Brooke?
Getting an education is a gift. A gift
Alan?
that many children
Here.
on the planet will never
Stephen?
receive. There's an old maxim that goes like this.
Ben?
It is only the ignorant that
Adam?
despise education. So be
Olivia?
smart and be grateful for the opportunity to get an education.
Olivia?
With something to think about,
No,
Mrs.
I'm
Shepherd.
calling for an Olivia.
Day or not, the choice is
You?
yours. Please join me in a moment of silence.
Silence. Harry? Lillian?
Here.
Mariana?
Here.
Reese? Harris?
Here.
Syed? Karmic?
Here.
Alec?
Here.
Marcus?
Here.
Ryan?
Here.
Thank you. Have a great
Trent?
day. We are Highlander Strong.
Janie?
Here.
Bruno? Emma? Dasha?
Here.
Yarden?
Here.
Sarah?
Here.
Caleb?
Here.
Dina?
Here.
Kate?
Here.
Claire?
Here.
Leda? Did I say that right? Yay, Sophia. Yay, you all exist.
I like it wisdom. Who doesn't?
I don't.
Wow.
Some days people just have different tolerances for existence, and that's okay.
That's fair.